Miss Ava, can you explain how sine, cosine, and tangent work again? Like, we've been talking about that stuff in school, and I just don't understand. What is SOH CAH TOA?
Sure, I can explain that to you. Okay, so like let's say you have a right triangle like this, right? And right triangle means that one of the angles is 90 degrees. Yes?
Yeah?
Okay, so let's say in this right triangle, I tell you that this is 3 here, this side length, this is 4, and I want you to find what this length is going to be right there. So that's an x. What can we do to figure out what that is?
Um, you could do a squared plus b squared equals c squared?
Yes, exactly. You can use the Pythagorean theorem. A squared plus b squared equals c squared. Now, let's say that instead of giving you like the 3, I don't tell you what that is. And instead of that, maybe I give you an angle. I tell you this one is 35 degrees here. We can't use the Pythagorean theorem here. So this is the kind of situation where you're going to use sine, cosine, tangent. So there's these 3 functions that we have, trig functions, sine, cosine, and tangent. And the SOH CAH TOA that they talk about is actually telling you that sine is opposite over hypotenuse, and this one is adjacent over hypotenuse, and this one is opposite over adjacent. So let's look at what that means exactly. Basically, when you have this sort of a situation, what I want you to do is there's like these 3 different labels here. So opposite, hypotenuse right there, and then adjacent. And we want to label all the sides over here with those 3 titles. First, you have to go, like the hypotenuse is always going to be the same in a triangle. So the hypotenuse is always the one that is across from the 90 degrees. So you're just going to put an H right there. Then you look at the angle right here, the one that is given to you, and you're going to go across from that angle is going to be the opposite. So you put an O, and then you're going to go to the only one that's left, and that's going to be the adjacent. So the one that's right next to it. So once you've labeled all the sides with, hypotenuse, opposite, or adjacent, then you are going to look at where the information is, the information that you have. So right now we have information right here that the adjacent is 4, and the thing that we're looking for is the hypotenuse. So that means that's the A and the H, right? A and H. And so we look at which of these 3 functions uses the adjacent and the hypotenuse. And as you can see, that is cosine. So then the way that these guys work is you're going to have cosine, and then there's going to be a blank equals a blank over blank. So these are the 3 places where you can fill something in. The angle is the one that goes in here, and then the other 2 are obviously going to be the ratios, adjacent and hypotenuse in this case. So that's all we have to do, is we just have to like fill them in. So we have the 35 degrees that goes right here, and then you have the adjacent, which is the 4, and then the unknown, which is the hypotenuse, the x, and then there is your equation right here. And so you can just solve from here. So you could say cosine of 35 degrees is equal to 4 over x. And since you're trying to solve for x and get the x by itself, that means that you can basically just flip these 2 guys, because there's an equal sign right here. So that means you can just switch them around like this, basically. Put the cosine on the bottom, put this one over here, and there we go. And then that's your answer. And you can put that into a calculator and it'll give you some nice number.
Oh, okay, but, like, I just don't, like, what is cosine? Is that, like,
Well, it's a function. It's like a math function.
is that, like, an operation, like a plus sign, or is it like an exponent?
No, it's a function. It's like, okay, like it's a ratio. So, like, let's say that there's a door, right? You open a door, and how wide you open it, like the ratio of the certain sides are always going to be the same, right? So like this one, let's say to this side is always going to have that same like ratio of their sides. So even if I extend this out and I make it longer like this, the ratio of like this part to this part is going to be the exact same as like the smaller one, right? For that specific angle. Does that make sense?
Yeah.
So that's what sine, cosine, and tangent tell us. It's just like a way of us indexing those two sides and the ratio of the two sides.
Okay. I get it.